Alright, this problem, the first problem here says graph theory, write the adjacency matrix for the following directed graph. So whenever it says directed graph, what it means is, it is saying that there will be arrows, that's all. Okay, so when you see a one side arrow, that's obviously B is connected to A, and if you see two-sided arrow or two-way arrow, that means both are connected to each other. So A is connected to C and C is connected to A. And what is this circular arrow? The circular arrow means it is connected to itself. Okay, so if you count in this particular problem, how many arrows are there? 1, 2, 3, 4 and 5, 6 and 7, 8, 9, 10. Okay, that's how many connections you have, and all it is saying is write the matrix. Matrix is nothing but putting the numbers in rows and columns. So I'll give you an example of a matrix if you don't know, but let me just copy this guy and put it in my whiteboard. So it is there. Now let me first write down all the connections that you are seeing there. Okay, and I always go in the order of A. Alright, A is connected to what all? That's the first thing you're going to see. Is A connected to B? No. Is A so first of all, A is connected to A? No. Is A connected to B? No. Is A connected to C? Yes. So you write AC. Okay. Is A connected to D? Yes. So you write AD. Is A connected to E? Is A connected to E? Yes. If I make any mistake, guys, you can always speak up. Okay, so yeah, we don't know how many rows are there, but I may have miscounted it, but that doesn't matter. We will find it out at the very end. Okay, so we have three connection points here from A. So A2, C, right? This one, and A to D, this one, and then A to E, this one. Okay. Now let's start with the B. Okay, so let's start with the B. Now, is B connected to A? Is B connected to A? Yes. So you write down BA. Is B connected to B itself? Yes. So you're going to put BB. Is B connected to C? B connected to C? Yes. So you put BC. And is B connected to D? So this is B. B is connected to D? No. Is B connected to E? No. So that's what it is. Now let's start with the C again. Is C connected to A? Yes. CA. Then C connected to B? No. C connected to C? No. Is C connected to D? Yes. Is C connected to E? Yes. Okay, so you're seeing that you're getting some values out of it. So we already made 9 connections. This is what it says, 9 connections are there. Now the last one, not the last one, but with D. So if you see, this is D, and D is like by itself. D is not connected to anything. Okay, so you don't have to write anything. Now E. So is E connected to anything? Yes, E is connected to, E is not connected to A, E is not connected to B, but E is connected to C. Okay, and then E is connected to D, and then is E connected to E? No. So if you count this, there are 11 connections. Yeah, Sneha and Sheila, they actually texted in the chat window, they mentioned. So there are total 11 connections that we have. But what exactly the adjacency matrix that they're talking about? Adjacency matrix is nothing but put a value 1 if two objects are connected. If put 0 if two objects are not connected. Okay, so the matrix goes like this. Pardon me my drawing skills. A, B, C, D, E. Okay, so then you put A, B, C, D, E. Right, so if you want, you can also draw columns like that, and you can complete the rows. Okay, so what this makes your life easy. In the above findings in this box, whatever we found, there are 11 connections. So you have to see there are 11 ones that comes, right? So now A to A, because there is no A to A connection, you're going to put a 0, right? Is A to B connected in this? No, so you're going to put a 0. Now CAC, you're going to put 1. AD, you're going to put 1. AE, you're going to put 1. All right. Now BA, yes, that's 1. BB, 1. BC, 1. BD, 0. BE, 0. Is C connected to A? Yes. So that's what this box says. CA connects to 1, so that's 1. CB, 0. CC, 0. CD, 1. CE, 1. Now there is no D at all, so you put all zeros. Is D connected to anything in this diagram? No, so that's why you get all zeros. Now what about E? E is connected to A. In this finding, what we found is it is not. E is connected to B? No. E is connected to C? Yes. E is connected to D? Yes. E is connected to E? No. So your final answer will be, you're going to write like this, the answer, you're going to write like this. 2 lines, but you write all the zeros and ones like that. 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, and 0, 0, 1, 1, 0. Okay, so that's your final answer. So let's check if that is matching with what we actually have on the website. Okay, so let me quickly grab that. Let me see if I have it in my downloaded files. Yeah, I think I downloaded this. So let's see if it is the same thing. No, it is 2011. So let me close that and let me go to the website and okay, so I'm going to select that and open that. Right? Oh, I got used to see this contest 2. I should search for contest 3. C3 juniors solution. Okay. All right. So that's what we got. So let me zoom in, and that's what we have. Is there a way I can copy this guy? Copy. Okay, you can verify. Did I copy in wrong place? Okay, so can you guys verify now? Okay, let me stop the recording so that we can talk. Alright, so this is the second problem that I'm copying here. Okay, so I'm enlarging this. I don't know if you can see this. This is A, this is B, this is C, and this is D. Okay, so now let me first write down all the possible connections. So whatever are available, let's write it down. So let's not write everything. Starting with A, there is AA. Okay, there is AB, AC, and AD. Wow, everything. AA, AB, AC, AD. Now starting with the B, you have BB. Sorry, there is BA, BA, and there is BB because B is connecting to itself. B is connected to C and B is connected to D. Okay. Now coming back to C. Is C connected to A? No. Is C connected to B? Yes. So you can put CB there. Then is CA, CB, CC? No, CC is not connected. Is CD connected? Yes. Now is DA connected? No. Is DB connected? Yes. And is DC connected? No. Is DD connected? No. So that's it. So all the places that are missing, you're going to put 0, 0, 0, 0, 0, and rest all you're going to put 1, 1, 1, 1, 1, like that. So your adjacent matrix is going to be 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. Did I copy them correctly? 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. So now let's see that. So first two rows are ones, we got it. Third row is 0, 1, 0, 1, we got it. Fourth row is 0, 1, 0, 0, we got it. Okay, so this is, you have to do this whenever you want to find the length of path, the paths of length 2 or more. You have to put an adjacency matrix so that you can multiply by itself. Okay, so now to find the length 2, you must square the adjacency matrix. Okay, so how do we multiply it? Like we discussed earlier, you write 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. Okay, and I'm going to put same thing here, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. Okay, so let's multiply this. So I'm not going to put the entire, I don't know if I have enough room here, but let's try. So I'm trying this first column, first row with the first column. Alright, so 1 times 1, 1 times 1, 1 times 0, 1 times 0. Right? So there are 2 zeros and 2 ones. So 1 plus 1, that is 2. So I'm doing like that. If you have any trouble, then you have to do the simpler matrix first, or you have to take a piece of paper and then write down all of them. Now, again, I finished the first column. So I wrote the first column value here. Now again start with the 1 times 1, 1 times 1, 1 times 1, 1 times 1. So 1 plus 1 plus 1 plus 1, that is 4. Now I start, that's second column is completed. So that's second column here. Now third column, you start with the same row again, but the third column. So 1 times 1, 1 times 1, rest all zeros. So that is 2. Okay. Now start the same row, but the fourth column. 1 times 1, 1 times 1, 1 times 1, that is 3. 1 times 0, that is 0. So you got 3. Now let's check if our first row is correct from the answer that was given. 2, 4, 2, 3. Make sense? You have to be a little bit smarter here. You have the same exact row and same exact columns. So do you want to do this again? No, you simply put. So that's how you have to gain the confidence. I don't want you to do like a labor intensive work. I want you to be smarter. So here, this first row and second row are exactly same, and you are multiplying exactly the same set of columns. So you will get the same exact thing. Now coming to the third row, 0 times 1, 1 times 1, 0 times 0, 1 times 0. How much is that? There's only 1, 1, right? So that's going to be 1. Now 0 times 1, that is 0. 1 times 1, that's 1. 0 times 1, that's 0. 1 times 1, that's 1. So you get a 2. Let me know if I make a mistake, okay? So otherwise we will end up getting a wrong answer. Alright, so now to remember where I am, that is third column that I am right now. So third row, but a third column. So 0 times 1, 0. 1 times 1, 1. This is 0. And this is 0. So that's 1. Now again, fourth column, 0 times 1 is 0. 1 times 1, that's 1. 0 times 1, that is 0. 1 times 0, that is 0. So you still have 1. So are we doing so far? Yeah, pretty good. 1, 2, 1, 1. Now, the last row with all the columns one more time. Right? 0 times 1, 1 times 1, 0 times 0, 0 times 0. So that's 1. 0 times 1, 1 times 1, second column. 0 times 1, 0 times 1. So that's only 1. 0 times 1, 1 times 1, 0 times 0, 0 times 0. That's 1. 0 times 1, 1 times 1. Yeah, somebody said I don't need to finish all of the rows. That is a smart way of thinking, but I want to make sure that I'm able to multiply 4 by 4 matrix with another 4 by 4 matrix. So that you will have to answer, if I ask a question, how many total routes that are length 2 or more, then you have to multiply all of them. But that you're right, because the question is how many are in starting from B. Okay, I missed that. Where are we? 0 times 1, 1 times 1, 0 times 1, 0 times 0. So that's again 1. Alright guys, so this is A, this is for B, this is for C, and this is for D. Now all you got to do is to add these 4, which is 11. Okay, I'm going to stop the video. Now you can ask questions.